Okay, so our objective today is to solve a non-homogeneous linear ordinary differential equation. We're going to use the example y double prime plus 16y equals 100e to the 2x with the initial conditions y of 0 equals 6 and y prime of 0 equals 2. It is not always the case in homogeneous or non-homogeneous linear ODEs that we get these initial conditions, but this happens to also be an initial value problem, so we kind of get to do a couple problems within one. So we know that it's non-homogeneous because this part right here is not equal to 0. This is a function of x as well. We know that our solution of y is going to be some combination of y sub h, which is the solution to the corresponding homogeneous equation from this half, plus a particular solution that is based on this half. Okay, so we're going to kind of do this in two parts and then add them together. So our first step is to solve y sub h. Okay, so when we're solving for y sub h, we know that we are actually solving the equation y double prime plus 16y equals 0. We can transform that to its characteristic equation, which is lambda squared plus 16 equals 0. This is a pretty straightforward quadratic to solve, and when we solve this, we find out that lambda is equal to plus or minus 4i. We remember that when you have imaginary or complex solutions to your characteristic equation, that comes out in the form of sine and cosine. So we end up getting a cosine of 4x plus b sine of 4x. And we have solved the first part of our equation here, y sub h. The second part is to solve y sub p. And y sub p is going to come from the fact that r is equal to 100e to the 2x. Since we know that r is a function of a constant times e to some power, we know that we can choose from the table, we choose y sub p to equal some other constant, we'll call it c, times e to the 2x, and that exponent stays the same as it did from r of x. So really the only thing that changes here is 100 becomes the more general constant. And then this is letting us use the basic rule. If you remember from the three rules, we have the basic rule, the modification rule, and the sum rule. Since this function here is just a single function of x, where we don't have like a sum of functions here, we don't have to use the sum rule, and the modification rule would only be applicable if this yp was the same form as either of the terms in yh, which you can see it is not. So then the next thing we do is that we have to find the derivatives of this. So we're going to find yp prime, which would just be 2c e to the 2x, and then yp double prime is 4ce to the 2x. We then plug those back into our very original equation for y double prime plus 16y equals 100e to the 2x. And we get 4c e to the 2x plus 16 times ce to the 2x, I guess I didn't need parentheses there, is equal to 100e to the 2x. Okay, and then I'm just going to go ahead and solve this for c by taking the coefficients on e. So throughout all of this, we're just going to equate our coefficients because we have e to the 2x in all of these terms, so we're just going to disregard those for the time being. And we're going to instead say, okay, if I have 4c plus 16c, that's going to equal to 100, and we solve for c. And we find out that c equals 5. Then we're going to go and plug this back into our original yp choice. So that actually means that our y sub p is equal to 5 e to the 2x. And then I can combine my yh from above and my yp from right here and find out that my general solution is y, let's say it's y of x, is equal to a cosine 4x plus b sine 4x plus 5e to the 2x. And this is our general solution to the non-homogeneous linear ODE that we set out to solve. I want you to go ahead and pause this video and try to use the initial conditions that we were given up here to find the particular solution for these general conditions from our general solution. So go ahead and pause your video and solve that, and when you are ready, come back on. Okay, so I went ahead and solved this, and I found out that if y of x is a cosine 4x plus b sine 4x plus 5e to the 2x, then my y prime is negative 4a sine 4x plus 4b cosine 4x plus 10e to the 2x. I plugged in 0 for my original equation, and I set that equal to 6. I went through and I solved that a was equal to 1. I did the same thing for my first derivative equation. I plugged in 0 for x, set it equal to 2, went through and I was able to solve and find b was equal to negative 2. So I conclude that my particular solution of this initial value problem of a non-homogeneous ordinary differential equation is y of x is equal to 1 cosine 4x minus 2 sine 4x plus 5e to the 2x.